So think of the ball of fire. Cool it, blow. See, what is happening? It's a very hot ball of fire and it's hurting a lot. It's in your hand, and now you're going to want to get rid of this, the sensation, the hot sensation it is producing when it is in contact with your hand. One thing that Adarsh is saying is we can blow it. That's one thing, right? What else? What else can we do? What else can we do? Transfer the ball from one hand to another. At least one hand will be relieved for some time. And if it is in this hand, you can put it in this hand. At least for some time, this hand will be relieved. Think of now you have 4 hands, right? Then from one hand, you can put it to another hand, or from the second to the third. Think of if you have 8 hands, even better. Extended conjugation, even better, right? The third thing is, like Advik is saying, throw it, throw up. You're not supposed to throw it on the floor. It's like a baby, okay? You can't throw it. It's your own. So you can just actually put it in the air. At least for some time, there will be no bond, and then the ball will come back to the hand. Throw it. It's there in the air for some time. For some time at least, there is no bond. And then it comes back. So do you understand? There are 3 ways in which you can get rid of the pain, the excruciating pain that you're getting from this hot ball of fire. So that is exactly what you will see in electron displacement effect. Think of this hot ball of fire as an intermediate, and you will see that the charges are a reason of sorrow in organic chemistry. Wherever you will see charges, they are going to be unstable as compared to a neutral molecule. Any day a neutral molecule is more stable than a charged species. Okay? So think of charges as a reason of sorrow, and we want to get rid of the charges. We want to get rid of the pain that this ball of fire or this charged species is causing. So one way is you can blow. So it's like an inductive effect. The other way is you can throw it in the air and then it comes back. That means no bond resonance, hyperconjugation, the second effect. The third one, take it from one hand, put it in another one. More the hand, extended conjugation, more the stability. From one hand to another, from second to third. So more the conjugation, more the stability. That's the resonance. And I'm sure out of the 3 scenarios, can you tell which one looks more relieving? You can't pick anything from outside. You have to make use of whatever you have. You can't make use of anything from outside, okay? So Shalini, you're saying can use cloth to hold it? No, you're not supposed to get anything from outside. So looks like, do you understand the transferring from one hand to another, and more the hands, more the stability. So resonance is going to be the most effective electron displacement effect. After that, it's this catch that you're playing, no bond, and then it's coming back. Do you understand when actually we're blowing the hot ball of fire? The bottom is already in touch with the hand. The bottom of the ball is in touch. You're actually blowing the top one, the topmost part of the ball. That is actually kind of like a psychological effect. An inductive effect is exactly like that. It is not as effective, but yeah, if none other effects are there, then it is one of the most appreciating and most applicable effect, to say the least. So let's now enter into different electron displacement effects. All right. Tell me, is it clear the